trajectory bends where no force should be near Mars, something quietly changed its mind. Observer, you didn't arrive here by accident. Somewhere between numbers and silence, this story was already waiting for you. 3i Atlas is not behaving like a comet should, drifting along the planetary plane, with improbable precision, accelerating gently without the cloud of loss that physics demands, holding a jet steady at a right angle to the Sun, as if direction itself were being chosen. What are the odds that an interstellar visitor would brush the gravity of Mars, then step aside without flame, without debris, without explanation? 15 spacecraft watched it happen and saw only a clean escape, a fragment from another star gliding through the dark, leaving questions behind. Listen, and let's drift through the silence together. The night sky rarely announces disruption with drama. More often it reveals its deeper questions through small deviations, numbers that refuse to settle, trajectories that bend slightly out of expectation, light that arrives carrying a quiet disagreement with theory. The passage of 3i Atlas near Mars belongs to this subtler tradition of discovery where science advances not through spectacle but through patient attention to what does not quite fit. As 3i Atlas approached the region of Mars, its motion initially appeared consistent with gravitational prediction. The object followed a path shaped by the Sun and planets, indistinguishable at first from countless other bodies tracked each year. Yet as the encounter drew closer, something unusual emerged in the calculations. The uncertainty corridor around its orbit did not widen and drift as models usually expect. Instead, it narrowed and held. Successive refinements kept the trajectory confined to a near-grazing geometry, one that lingered longer than probability alone seemed to justify. Then, over only a few solution cycles, the path lifted cleanly away from the planet. No explosion marked the change, no sudden brightening, no expansive dust cloud, no visible expenditure of energy accompanied the maneuver. On paper, the object simply missed Mars. In practice, the numbers recorded a precise adjustment without an obvious physical cost. Moments like this sit at the boundary between explanation and description. Photometric data showed ordinary fluctuations for an active body, but nothing violent enough to account for the timing and accuracy of the shift. Orbital residuals settled obediently once the new path emerged, as if the correction had always been there waiting to be revealed. A conservative interpretation holds that early uncertainties exaggerated the apparent risk, and that the encounter was never truly close. Yet the sharpness of the bend, paired with the absence of a compensating outburst, left behind a tension that refinement alone could not fully erase. As observations accumulated, other characteristics of 3i Atlas reinforced this quiet unease. Its orbit lay unusually close to the planetary plane, a narrow region most interstellar objects should statistically miss. Random debris arriving from distant systems is expected to approach from steep inclinations scattered by the chaotic history of stellar encounters. Alignment of this degree is not impossible, but it is uncommon enough to register as more than noise. It reads as a statistical whisper suggesting either chance at the edge of probability or a selection process not yet understood. The object's chemistry added another layer of ambiguity. Spectral signatures of nickel and iron leaned away from the distributions typical of untouched cometary material, edging instead toward ratios more often associated with matter, shaped under sustained heat and pressure. This did not imply fabrication, but it complicated the picture of a simple primitive fragment. The data resisted a single narrative offering instead a set of properties that fit imperfectly within familiar categories. Jets streaming from the surface further challenged expectation. High-resolution imaging revealed narrow, persistent flows that remained remarkably stable, even as the object rotated. One prominent jet held nearly perpendicular to the solar direction, resisting the geometry imposed by solar heating, radiation pressure and solar wind. In standard comet models, such behavior demands rotational modulation, or dramatic changes in activity, neither of which appeared clearly in the data. The physics did not collapse. It stretched quietly, asking for additional terms. Perhaps most telling was what remained absent. Across presentations and visualizations, no definitive statement of size accompanied the imagery. Without a clear radius or diameter, mass estimates floated without anchor. calculations of non-gravitational acceleration already strained by the lack of a visible debris cloud became increasingly speculative. The missing scale functioned like a silent variable shaping every result that depended upon it. Without mass force becomes inference rather than measurement. Placed in context, the contrast sharpened. Earlier interstellar visitors had been fleeting and small, leaving behind novelty rather than consequence. This object appeared to occupy a different regime entirely. When inferred dimensions climbed into the kilometre range, they disrupted the smooth statistical curves long used to describe interstellar debris. If such bodies were common, smaller fragments should have arrived in abundance long before. Instead, with only a handful of known visitors, this one already claimed the extreme edge of probability. Either the distribution of interstellar matter is poorly understood, or the sample reaching us is not random in the way theory assumes. Public framing remained careful. Official language emphasized rarity and beauty, describing an unusual comet pushed to extremes by circumstance. Diagrams illustrated how sunlight might drive jets and sculpt dust into elegant forms. The tone reassured, suggesting a puzzle rather than a disruption. Yet certain questions about scale alignment and missing mass loss persisted just beyond the frame acknowledged indirectly or deferred altogether. To classify an object is not the same as to explain it. Categories provide stability, but they also absorb uncertainty until they can no longer stretch. A body that strains multiple models at once does more than challenge equations. It tests how much ambiguity a framework can hold before revision becomes unavoidable. In the quiet intervals between explanations, another possibility emerges not as a claim, but as a reminder that nature may still possess modes of formation and behaviour not yet mapped. Observations from Mars orbit added depth rather than drama. Viewed from the side, the halo of 3i Atlas resolved into asymmetric structure that resisted dismissal as perspective or blur. The data returned to Earth without announcement, carrying not a verdict, but a refinement of doubt. The familiar textbook story of comets' sunlight, sublimation, dust tails remained broadly intact, yet each new measurement pressed gently against its edges. Taken together, the evidence did not demand alarm, nor did it offer closure. Each anomaly could be eased back toward a natural explanation by adjusting parameters or invoking unfamiliar material properties. Yet the full portrait remained uneasy. 3i Atlas began to resemble a relic rather than a visitor. In the ordinary sense, a natural object shaped by processes our equations only partially capture. Such an interpretation neither confirms fear nor resolves curiosity. It shifts the question instead, asking where in the galaxy such objects are born and what histories leave behind survivors of this kind. Science advances comfortably when answers arrive cleanly. It advances more honestly when uncertainty is allowed to remain visible. In the case of 3i Atlas, the most restrained conclusion may also be the most demanding that the object is natural, but that nature itself is broader than our current maps. The universe has not contradicted us. It has simply reminded us that our laws are drafts written lightly against a sky that continues to move. If the first questions raised by 3i Atlas concerned motion and scale, the next emerged more quietly from interaction, how the object exchanged energy with its surroundings, and how little evidence it left behind while doing so. As the visitor continued beyond its close passage near Mars, attention shifted from trajectories to signals from geometry, to the faint physical traces that accompanied its movement through space. This transition marked a deeper stage of inquiry, one less focused on where the object travelled and more on how it functioned. The first clear indication came not in the visible light, but in radio observations. Against the steady background of cosmic noise, astronomers detected a narrow absorption feature at the frequency associated with hydroxyl molecules. The signal was subtle and easily overlooked, appearing as a small notch rather than a spike. Yet repeated measurements revealed a consistent pattern. The absorption moved across the spectrum with the same Doppler shift as 3i Atlas, matching its velocity precisely. This behaviour ruled out random interference and anchored the feature to the object itself. Hydroxyl absorption carries modest but significant implications. It indicates the presence of gas that is neither frozen nor violently expelled but gently released and sustained. In physical terms, it suggests activity without disruption. The object was not inert. yet it was not shedding mass in a dramatic or chaotic way. Instead, it appeared to be breathing slowly, exchanging material with space at a level just sufficient to be detected. This confirmation sharpened earlier concerns. Orbital calculations consistently showed a small, non-gravitational acceleration acting on 3I's Atlas, a persistent deviation that gravity alone could not explain. In conventional comet physics, such acceleration arises from asymmetric outgassing, where escaping material acts like a weak thruster. The relationship between thrust and mass loss is well understood. To generate the observed acceleration, the object would need to lose a substantial fraction of its mass. Such loss should be unmistakable, producing a bright and extended cloud of gas and dust. No such cloud appeared. Telescopes across multiple wavelengths found the space around 3I Atlas to be surprisingly clean. Activity was present, but not at the scale demanded by the orbital data. The thrust was real. The expected debris was missing. This discrepancy did not overturn physical law, but it exposed an imbalance in the models. Either mass was being expelled far more efficiently than expected, or momentum was being transferred through mechanisms not yet fully characterized. Infrared observations added further complexity. Measurements sensitive to thermal emission indicated that the nucleus retained more internal heat than simple models predicted for an object at that distance from the Sun. Attempts to reconcile this involved adjusting surface reflectivity, porosity, and rotation, yet each modification introduced new tension. Cooling the nucleus degraded the orbital fit. Preserving the trajectory restored the thermal excess. The data resisted convergence, as if the object were maintaining an internal state not easily reduced to familiar parameters. High-resolution imaging revealed that the surrounding material was not uniform. What first appeared as a smooth halo gradually resolved into fine structure. Thin filaments emerged tracing narrow jets that radiated in several directions. At least 7 such features could be identified, each persistent over time. The pattern differed from the simple fan expected when a single sunlit region drives activity. Instead, it suggested distributed sources across the surface active in parallel. A natural explanation remains possible. Fractured terrain and layered composition could expose multiple pockets of volatile material, each venting along paths shaped by local structure. Under the right conditions, such vents could remain stable longer than expected. This interpretation does not violate known physics, but it demands an unusual combination of material properties and geometry sustained over long intervals. An alternative reading, more restrained than speculative, focuses on efficiency rather than intent. A network of small persistent jets could allow an object to trade minimal mass loss for precise control of spin and motion. The same physical processes that produce ordinary outgassing could, under specific conditions, yield behavior that appears finely tuned. The data alone does not compel a choice between these interpretations. It merely keeps both in play. Throughout this phase of observation, access to the highest resolution data remained cautious. The sharpest images, capable of tracing every filament and asymmetry, moved slowly through internal review before partial release. Public versions demonstrated activity but stopped short of resolution. This restraint reflected not secrecy, but awareness that premature conclusions can harden narratives before the evidence has fully matured. Opportunities for further study emerged briefly. As 3I Atlas passed through regions monitored by distant spacecraft, proposals were made to listen for additional signals or anomalies. Whether such efforts would reveal anything remained uncertain, and not all were pursued. The object continued on its path, indifferent to the scheduling constraints of observation. What persisted was a pattern of consistency. Across instruments and wavelengths, the behavior of 3I Atlas remained quietly unusual. Each anomaly could be softened by parameter adjustments. Taken together, they formed a coherent but incomplete portrait. The visitor began to resemble less an exception, and more a probe testing the boundaries of current models without crossing into contradiction. At this stage, the question shifted again. Rather than asking whether the object was natural or artificial, researchers confronted a subtler issue: how broad the category of natural truly is. An object formed under extreme conditions elsewhere in the galaxy could easily appear engineered when judged by the standards of a calmer environment. Complexity alone does not imply design. It may instead reflect histories more violent or more ordered than those familiar to us. Science does not require immediate resolution. It advances through accumulation patience and the willingness to hold uncertainty without forcing it closed. In the case of 3i Atlas, the value of the encounter lay not in answers, but in the refinement of questions. The object did not demand redefinition of physics, but it invited expansion. As observations concluded and attention shifted elsewhere, the data remained. The visitor moved on, carrying its history beyond reach. What it left behind was not a conclusion, but a reminder that the universe is capable of producing structures that sit precisely at the edge of our understanding, obeying known laws while revealing how incomplete our maps still are. As 3i Atlas continued its journey, attention shifted from motion and interaction toward structure. Not structure as a simple outline, but as a layered presence, revealed gradually through light, heat, and geometry. Each wavelength added a quiet dimension, and together they formed an image that resisted collapse into a single explanation. What emerged was not contradiction, but depth. In visible light, 3i Atlas did not resemble the familiar portrait of a comet. There was no ragged fan of debris, no chaotic plume dissolving under solar pressure. Instead, telescopes recorded a smooth teardrop-shaped cocoon of dust wrapped around a compact core. The boundary of this cocoon appeared unusually clean, almost polished. Starlight bent gently around its edge, outlining a symmetry that felt calm rather than fragile. Where many comets appear loose and temporary, this object looked contained, as if its material preferred cohesion to dispersal. That cohesion hinted at strength. Not reinforcement in any engineered sense, but material properties capable of resisting fragmentation. Ordinary comet models predict irregular clumps and uneven flows as volatile material escapes. Here dust followed a quieter geometry. The core remained tight and luminous, a concentrated centre that refused to blur into the surrounding haze. Ultraviolet observations expanded the picture outward. Beyond the visible cocoon lay a vast halo of atomic hydrogen glowing faintly as solar photons broke apart water molecules. Hydrogen halos are common around comets, but this one extended far beyond what models predicted for an object at this distance from the Sun. Its size implied sustained processing of water at a scale difficult to reconcile with the modest surface activity seen in visible light. The contradiction remained gentle but persistent. To maintain such a halo, significant quantities of water must be present and active. Yet the surface appeared calm, lacking the violent disruption typically associated with strong sublimation. One explanation suggested deeply buried ice, insulated by dense layers of dust and rock releasing vapour slowly through confined pathways. Another pointed toward internal heat retained from formation, or compression feeding activity from within rather than from the surface alone. Neither option violated known physics. Both required conditions that extended beyond the usual examples. Perspective from Mars orbit sharpened these impressions. Side-on imaging broke the flattening effect of Earth-based views. Against steady star fields, the halo revealed a symmetry. One side of the dust shell thickened into a pale crescent, while the opposite side thinned as if eroded or swept away. This structure persisted across frames, resisting explanation as blur or artifact. Its orientation did not align neatly with solar direction or simple rotation. Farther out, a faint tail extended into space, angled away from the expected axis. Solar wind and radiation pressure can bend such features, but the tilt remained offset enough to raise quiet questions. Dust and gas that should have traced a single obedient line instead framed the object with arcs and slants. Each deviation was small. Together they formed a pattern of misalignment that felt deliberate only in its consistency. Infrared measurements returned focus to the core. Thermal data suggested that the nucleus retained warmth beyond what a passive body should hold at that distance. Attempts to reconcile this involved adjusting surface texture, reflectivity, and composition. Yet each solution that cooled the core tended to disrupt the orbital fit, while those that preserved the trajectory restored the excess heat. The object appeared to balance competing properties: gentle thrust without visible exhaust warmth, without a clear source structure, without violence. When laid together, these observations resembled a cross-section through history. Dust wrapped around, vapor around a dense interior. Layers suggested sequence rather than accident. The emerging image was less of a crumbling remnant and more of a survivor shaped by forces strong enough to compress the heat and preserve. At this stage, the idea of an artifact returned in a quieter sense. Not artifact as construction, but as outcome. A natural artifact formed by process rather than intention. Science is filled with such examples. Diamonds forged under pressure. Neutron stars compressed beyond ordinary matter. Their strangeness reflects origin, not design. If 3 Atlas belongs to this category, then its anomalies are not signals but fossils, records of conditions that once existed elsewhere in the galaxy. Its alignment, chemistry and structure may be remnants of a system where gravity, heat and time combine differently than here. Seen this way, the object does not challenge physics so much as expand its context. This framing resolves one tension while preserving another. It allows the object to remain natural without demanding familiarity. It acknowledges that current models are tuned to local examples and that extrapolating them across interstellar space carries uncertainty. The universe has had billions of years to explore configurations we have barely imagined. Yet acceptance does not bring closure. A natural artifact of this kind would still carry significant implications. It would suggest that planetary systems can produce coherent, resilient bodies capable of surviving ejection and long interstellar travel. It would imply that interstellar space is seeded not only with fragments, but with structured remnants that endure. Listener, this is where science often shifts quietly. Not at the moment of proof, but at the moment perspective widens. The object does not need an extraordinary origin to be extraordinary in consequence. Its passage gently reshapes what ordinary might mean. As the full set of observations settles into archives, no single image demands revision of physical law. Together they invite revision of expectation. The visitor neither confirms fear nor resolves wonder. It occupies a calm middle ground where uncertainty becomes a form of knowledge. For now, 3 Atlas recedes into distance. Its layered form dissolves back into faint light. Instruments turn away. The sky returns to stillness. What remains is not an answer, but an expanded sense of possibility. Somewhere beyond our reach, something ancient still moves. As 3 Atlas drifted farther from Mars and deeper into its quiet arc, the focus of study shifted once more away from shape and composition and toward motion itself. Motion in astronomy is rarely ambiguous. Paths are written by gravity, adjusted by mass, softened by distance. When an object moves, it leaves behind a clear mathematical trace, and yet in the case of 3 Atlas, that trace never fully settled. Early trajectory solutions suggested that gravity alone could explain its path. The equations behaved as expected, planets exerted their measured pulls, and the Sun held the dominant role. But as observations accumulated, a subtle discrepancy remained. The object arrived at predicted positions slightly early, then slightly late, never enough to alarm but enough to persist. Over time, those residuals traced a pattern that refused to dissolve into noise. In comet physics, such deviations are familiar. They are usually attributed to non-gravitational acceleration, a gentle push produced when gas escapes unevenly from the surface. Outgassing acts like a faint thruster, altering the orbit while shedding mass into space. When this happens, the evidence is normally visible. Dust clouds bloom, tails brighten. The price of motion is paid openly in debris. For 3 Atlas, the price was missing. Calculations showed that to account for the observed acceleration, the object would need to lose a substantial fraction of its mass. Not a trace amount, but an amount large enough to surround it with a luminous cloud detectable by nearly every instrument watching. Yet the space around it remained remarkably clear. No vast plume appeared. No surge in brightness announced the exchange. Motion occurred without spectacle. This contradiction did not imply impossibility. It implied incompleteness. Either the mass loss was occurring in a form difficult to detect, or the mechanism producing acceleration was not the familiar one. Both options required patience rather than alarm. Several natural pathways were explored, One proposed that extremely fine particles were being released too small to scatter light efficiently. Another suggested interaction with charged particles in the solar wind, allowing momentum exchange without visible dust. A third pointed toward internal processes that vented material directionally while retaining cohesion. Each idea fit parts of the data, none fit all. The result was not confusion but layering. Each hypothesis added another translucent sheet to the picture, deepening rather than clarifying the view. The object's rotation introduced further complexity. With a measured spin of roughly 16 hours, any surface-driven jet should trace a spiral or fan as the body turned. Yet one prominent jet maintained a near-constant orientation close to perpendicular to the Sun. Frame after frame confirmed the alignment. Rotation continued, direction did not. Under ordinary conditions, such behavior would require precise compensation. A vent would need to adjust continuously, countering spin to hold its line. Random surface features do not behave this way, and yet invoking intention added nothing measurable. Physics remained sufficient even if stretched. At this stage, scientists often return to fundamentals. They compare the object not to expectations but to limits. What is the weakest force capable of producing the observed effect? What is the smallest adjustment required? In the case of 3i Atlas, the answers remained small. The forces were gentle, the changes incremental. The mystery lay not in magnitude, but in coordination. Listener, this is where data becomes reflective. Not because it fails, but because it succeeds too quietly. Nothing breaks. Nothing explodes. The universe simply declines to be rushed. As more instruments joined the observation campaign, the pattern repeated. Infrared measurements suggested internal warmth. Ultraviolet data revealed extended hydrogen. Optical images showed symmetry. Orbital fits required thrust without debris. Each wavelength told the same calm story from a different angle. Together they formed coherence without closure. Such coherence often precedes understanding. It signals that the object belongs to a category not yet well described rather than to a violation of known law. Astronomy has encountered this before. Pulsars were once errors. Quasars were once misidentifications. Their resolution did not come from abandoning physics, but from widening it. In that context, 3i Atlas begins to resemble a transitional object, not a bridge between natural and artificial, but between familiar and unfamiliar natural processes. Its behavior suggests that interstellar space may deliver not only debris but survivors, bodies shaped by pressures and histories rare enough to escape easy classification. As observation windows closed and instruments turned elsewhere, the object continued onward. Its acceleration diminished as distance grew. Its jets faded into faint structure. The equations slowly simplified again. Gravity reclaimed its dominance. Silence returned to the plots. What remains is not a conclusion but a posture, an understanding that nature does not owe us immediacy. Some answers arrive as resolution, others arrive as permission to wait. Tonight the universe whispers again, not with revelation but with restraint. It reminds us that motion can occur without noise, that complexity can remain gentle, and that not knowing is sometimes the most accurate state. The stars resume their steady patterns. Data rests, and somewhere along its long path, 3i Atlas continues carrying with it the quiet possibility that our maps are still drafts. When the final observation windows closed and the last scheduled instruments turned away, 3i Atlas did not conclude its story. It simply moved beyond the region where constant attention was possible. The object continued outward, its signal thinning its brightness, fading into the background of distant stars. What remained behind was not a single answer, but a quiet accumulation of understanding. By this stage, the scientific record around 3i Atlas had become unusually dense. Measurements from many angles and wavelengths converged on a shared description. The object was active yet restrained. It carried internal energy yet released it sparingly. It responded to gravity yet not exclusively. None of these traits alone demanded revision of physics. Taken together, they invited humility. Astronomy often advances by reduction. Complex systems are simplified until patterns emerge. With 3i Atlas, the reverse occurred. Each simplification left something behind. Remove the jets and the orbit remained unsettled. Remove the orbit and the thermal profile resisted cooling. Remove the heat, and the chemical ratios stayed unfamiliar. The object refused to collapse into a single explanation. This resistance does not imply intention or design. It implies history. Every body in space is an archive shaped by events that occurred long before observation. For objects formed near stable stars and quiet disks, those histories align with what our models expect. For interstellar visitors, the archive may include conditions rarely sampled, perhaps never directly observed before. In this light, 3's Atlas appears less like an anomaly and more like a survivor, a remnant shaped by forces that operate infrequently but not impossibly. Collisions between massive worlds, tidal stripping near dense stars, ejection from systems undergoing violent rearrangement. Such events are uncommon, but the galaxy is old. Given enough time, even rare outcomes become inevitable. The data suggest that whatever shaped 3I Atlas left it layered, resilient and internally complex. Dust formed a controlled shell. Hydrogen extended far beyond expectation. Heat lingered beneath the surface. Motion remained efficient. These are not signs of fragility, they're signs of endurance. As models expanded to accommodate these traits, the language around the object softened. It became less useful to ask whether 3 Atlas was natural in the narrow sense. Instead, the more accurate question became how broad nature truly is. The answer, as always, appears to be broader than convenience allows. Traveller. This is the quiet shift that science often makes without announcement. Categories do not collapse, they stretch. Boundaries move outward. Textbooks change slowly, but the universe changes them nonetheless. The absence of finality is not a failure, it is a feature of careful observation. A conclusion reached too quickly would say more about expectation than evidence. In choosing patience, the scientific process remains aligned with the cosmos it studies. As attention fades, so does urgency. 3 Atlas will not return on human timescales. Its path leads onward into regions where sunlight weakens and jets fall silent. Whatever internal processes once shaped its motion will gradually quiet. The object will become what most bodies in space already are, cold distant and largely inert. Yet its passage leaves a trace, not in debris or impact, but in understanding. It reminds us that interstellar space is not empty of structure, that the debris between stars can include bodies with memory, that the universe is capable of preserving complexity across immense distances and times. In the end, the safest conclusion is also the most precise. 3 Atlas is consistent with nature but not with simplicity. It fits within physics but stretches our familiarity with it. It does not demand new laws, only careful listening. Silence is the language of distant worlds. In that silence, objects like 3 Atlas move without explanation, yet not without meaning. They pass through our systems, briefly offering a glimpse of processes that operate elsewhere, under conditions we have yet to fully imagine. You are not lost in space, you are part of it. The same laws that carried 3I Atlas across the stars also shape the quiet ground beneath us. The difference lies only in scale and perspective. Tonight the stars will keep their silence, and that is enough. As the final images settle into silence, the story of 3I Atlas does not close so much as it softens. What we have seen laid gently side by side is not proof of certainty, but a portrait of patience. Data becomes shape, shape becomes suggestion, and suggestion becomes a quiet reminder that the universe does not rush to explain itself. Dreamer. If this journey felt unfinished, that is because it was meant to be. 3 Atlas continues on its long path, carrying with it the memory of distant forces and forgotten origins. It asks nothing of us except attention. In return, it offers perspective. We are small beneath the stars, but not invisible. Our questions matter even when answers remain out of reach. There is humility in admitting that our laws are still drafts written in pencil, against a sky that has been composing itself for billions of years. There is peace in realizing that wonder does not require resolution. Some truths are meant to remain slightly out of focus, glowing softly at the edge of understanding. Tonight the universe is still awake, still moving, still whispering through light and gravity and time. If this story found you here, you're welcome to rest beneath it a little longer. Stay curious. The universe will keep watch,